Hello, this is Math with Beth, and we are doing exponents today. So we're going to go over the rules and then try some to make sure you see how they are used in the problems. So up top, these are the rules up here. They look fancy with all the letters, but let me make sure you understand what it's saying. So all this first one's saying is if you are multiplying two different things that are the same base, so two x's, two y's, it doesn't matter. As long as they are the same base, whatever their exponents are, instead of multiplying, you actually add them. When you have one base to a power and then you're raising it to another power, these are the ones that you multiply. So these are the two people get confused the most. So make sure you see when do you add the exponents and when do you multiply. When the two things are being divided, again, make sure they have the same base. So it doesn't have to be an x, it could be a y, it could be a 2. As long as the bases are the same, then you will subtract the exponents. When you have a negative exponent, what you're going to end up doing is actually making it a positive exponent by moving the whole thing. So if it was x to the -2, that would become 1 over x to the +2. And if it started at the bottom, so 1 over x to the -2, we can make this one positive by bringing it up top. So negative exponents end up moving either to the top or the bottom, and then they become positive. And finally, just making sure you know that anything to the 0 power just becomes 1. Not x to the 1, just 1. Okay, so let's try some of those and see if they make sense in these problems. So number 1, hopefully you see, is just like this one. So I am going to just add those exponents and call it a day. But number 2 is just showing you how to do the same type of thing with something a little more complicated. So don't mess up these rules with normal numbers. I'm doing a 3 times a -2. So that has always been -6. It still is. It's the x to the 4th times x to the 2nd where I need to use these new rules and add those to get x to the 6th. So as you're doing these new rules, make sure you're still doing the normal numbers the same as you've always done. Number 3, x to the 8th over x to the 2nd. I'm going to subtract those so I get x to the 6th. Easy. But number 4, I'm just trying to show you to be careful if there are more x's or y's or z's on the bottom than the top, you're still going to subtract, but your answer is going to go on the bottom because that's where there was more of the x's. So 7 minus 4 is 3, but where should those 3 x's go? On the bottom, because that's where there was more. So now that there's nothing left on top, just make sure you put a 1. X to the 3rd raised to the 4th. This is just like this rule. So I'm now going to finally multiply those numbers. And then number 6, same idea, but again, I'm throwing in a normal number to make sure you see that you have to handle these differently. The x to the 4th raised to the 2nd, I am going to multiply those, but 3 to the 2nd, I don't multiply that. I do 3 times 3. So I square the 3 just like it says to. So you should be treating the numbers in front differently than you're treating the exponents. 7, similar to this one, there's more x's on the bottom, so my x's are going to be on the bottom, but I just threw some normal numbers in again so that you could handle those. So 4 over -8, think of it as a fraction. We can reduce that fraction, right? So it's going to be a -1 over 2. The negative really can go on the top or the bottom. It just can't go in both. If you put it in the top and the bottom, really those wipe each other out. So if there was one negative before, there should still be one negative, but it really doesn't matter where you put it. For the x's, remember there's 2 left over, but they should go on the bottom. 8, doesn't matter how much is going on in here. If the whole thing is being raised to the 0 power, that whole thing just becomes a 1. Number 9, I'm just trying to show you how to handle a negative exponent that's in the middle of all this other stuff. So make sure you understand that that 3 has nothing to do with that x to the -2nd. So the 3 should still be on top. The x to the -2nd goes to the bottom and becomes positive. and the y to the fourth stays on top. And then finally, I threw a pretty tricky one on here. All of this stuff is being raised to a negative power. So the first thing I'm going to do is change that negative power to a positive power, which means I'm going to flip everything. So now I just treat it as if it was all of this raised to the second. So 5 to the second power means 5 times 5. Y to the second power just becomes y to the second power, because it's kind of like there was a 1 there that we multiplied. 3 to the second becomes 9. X to the second raised to the second becomes x to the fourth. Then just double check if there's anything else you can reduce. If 25 and 9 had something that I could reduce them by, I would. So those are done. So those are some examples of using all of these exponent rules. Hope that helped, and I'll see you next time.